In this example, I need to solve the following system of equations using the substitution method. Here is my system of equations. What type of equations are these? Notice the highest exponent on any of the variables is a 1, so I have two linear equations in two variables. And here are the steps to solve a system of two linear equations in two variables using the substitution method. Here are my equations, and I always label them. Here's equation 1, and here is equation 2. Step 1 says solve one of the equations for either variable. If possible, avoid fractions. To avoid fractions, we solve for the variable that has a coefficient of a 1 or a -1. Do I have that in this case? Yes, I have a -1 coefficient on the y in the second equation. So what I'm going to do is I'm going to solve equation 2 for y. So I have 2x minus y equals -13. To get y by itself, I'm going to subtract 2x from both sides. 2x minus 2x is 0. I have -y equals, unlike terms, it doesn't matter which order I write them in. I'm going to put -2x minus 13. Last thing, to solve for y, I'm going to have to divide both sides by -1. And on the right-hand side, you make less mistakes if you divide each term by -1. So -y divided by -1 is y, equals -2x divided by -1 is positive 2x. -13 divided by -1 is positive 13. So I have completed step 1. Step 2 says substitute the results of step 1 into the other equation. So I am going to have to take y equals 2x plus 13, and I'm going to put it into my other equation, which was equation 1. So I'm going to substitute into equation 1. Notice I used equation 2. Now I'm using the other equation, equation 1. So I'm going to get 5x plus 2 times, instead of y, I'm going to have 2x plus 13 equals -1. So now I've completed step 2. Step 3 says solve the resulting equation from step 2. So now I need to solve this equation. It's a linear equation in just x. So I have 5x plus, distribute the 2 in. 2 times 2x is 4x. 2 times 13 is positive 26 equals -1. I have like terms. 5x and 4x is 9x plus 26 equals -1. Subtract 26 from both sides. I get 9x equals -1 added to -26 is -27. Finally, divide both sides by 9. I get x equals -27 divided by 9 is -3. So that is step 3 completed. Now in step 4, I need to find the value of the other variable by back substitution. So that means I'm going to take x equals -3 and plug it either into equation 1 or equation 2. It doesn't matter which one. I'm going to use equation 2 since the numbers are slightly smaller. So using equation 2, I'm going to get 2 times x. X is -3, so that's 2 times -3 minus y equals negative 13. 2 times negative 3 is negative 6 minus y equals negative 13. Add 6 to both sides. I get negative y equals negative 13 plus 6 is negative 7. Divide both sides by negative 1. I get y equals negative 7 divided by negative 1 is positive 7. So I have completed step 4. Normally, we write the solution to systems of equations as ordered pairs. So my solution, written as an ordered pair, x-coordinate first, so it's negative 3, comma, the y-coordinate of 7. So that is the solution to this linear system of equations, and we can check the solution in both of the original equations. So if I wanted to check my solutions, I'd plug x equals negative 3 and y equals 7 into both equations. So equation 1 becomes 5 times x is negative 3 plus 2 times y, which is 7, should equal negative 1. 5 times negative 3 is negative 15, plus 2 times 7 is 14. Does that equal negative 1? Yes, negative 15 plus 14 is negative 1. That's one true statement, but you have to check it into both equations. Does 2 times x, which is negative 3, minus y, which is 7, does that equal negative 13? 2 times negative 3 is negative 6 minus 7. Does that equal negative 13? Negative 6 minus 7 is negative 13. Negative 13 equals negative 13. Two true statements, so you know your solution is correct.